This is an expressive practice sample. You have been asked to render a message for a deaf middle school student. The class is starting their unit on plate tectonics. You will have a 1-minute warm-up followed by a 1-minute break. After the break, you will begin interpreting or transliterating. The warm-up will begin momentarily. Okay, now we're going to be starting on tectonic plates. So for this, we need to think back to our layers of the earth. Do you guys remember what the layer of the earth is that we live on? We live on the crust, correct? So the crust of the earth. There's a theory. Now we need to remember that just because it's a theory doesn't mean it's just an idea. It's not really official at all, okay? We have to remember the difference between a theory and a law. It's hard for a theory to become a law in science, even if 99% of scientists agree, right? Anyway, so plate tectonics is a theory that the crust of the earth is made of a bunch of parts, okay? And these parts are called plates. And these plates move around on the earth's surface, okay? These plates moving around change what the surface of the earth looks like, okay? It helps explain a lot of things that we see and experience and that happened on the Earth's crust. So scientists first started having this idea in like the 1960s. And basically what it says is that the mantle, right, which is below the crust, we talked about before about how the mantle kind of circulates, right? How stuff will sink closer to the core of the outer core, heat up and rise, and then it'll cool off and it'll sink again. So it kind of goes in circles, right? So this theory is that moving in those circles moves the plates of the crust on top of it. These plates are all kinds of shapes and sizes. Okay, we have large plates, medium-ish plates, and a handful of small plates. Okay, so there's 7 really big ones. They're like the size of whole continents or whole oceans. They're really, really big. Then we have a couple medium ones that are the size of different regions. They're a lot smaller than the ones that make up whole continents and whole oceans. And then there's just some little ones, just a couple little plates. Now these plates, we can't see them move. They move pretty slowly because that process of the core heating and cooling and cycling and rising and falling can be really slow. And keep in mind, these crusts can these plates, excuse me, can be the size of a whole continent. If I asked you to go outside and push a continent, it would be really hard, right? It would be impossible. So, a continent on like a plate can be really heavy and can be really hard for it to move very fast. And when they move, they create different boundaries. So, a boundary is an area where two plates touch. And where these two plates touch, a lot of different things can happen. Okay. They can either, there's three kinds of things that can happen. They can converge, diverge, or slip past each other. Okay. And these things happening can make a lot of stuff happen on the Earth's crust that are a big deal. These plates are used to kind of explain earthquakes. When they're moving past each other, they make earthquakes. Volcanoes can happen when there's like a space between two plates and magma comes up from the mantle through the spaces between two plates, and it builds and builds and builds to make the whole volcano. It can also make mountains. It can make huge mountains. When two plates run into each other, they make mountains. But sometimes they can also break or pull apart. But this moving can have a really big impact on what our Earth looks like also. We talked before about the three kinds of boundaries that happen when plates are right next to each other, right? So they either converge, diverge, or slip, right? First, we're going to talk about divergent boundaries, okay? At a divergent boundary, the two plates are moving away from each other. They're moving away from each other. So what do you think happens when these two plates move away from each other? Yeah, everything kind of falls in right there. So if I have my two hands and I'm holding water in my hands, kind of like those two plates, right? And if I pull my hands apart, the water is going to fall through in the middle. The difference is when I move my hands away, there is nothing below. So it's just going to fall through. But with the ocean, when this happens in the ocean has that magma underneath it from the mantle, right? So that magma can come up through that crack. So if we were to cover our table in pieces of paper and then moved two pieces of paper away from each other, what would happen to the other edges of papers on the table?